Welcome to qnawire.
In this problem, we need to solve for the distance h, for which the instantaneous center of rotation is point C upon impact. So, to solve the problem, we will use the principle of impulse and momentum. So, I have here a sketch of the problem. So, what happened in the problem is that, so in the first part, you can see that a bullet with mass mb is fired at a velocity v sub o towards a suspended rod with mass mr, initially at rest. So, at a distance h from its center. So, that's in the first part of the sketch. Upon impact, the rod rotates with an angular velocity omega, and the center G moves with a velocity Vg. So, that's on the last part of the diagram. So, by the way, in the second part of the diagram, you can see the forces acting on the rod, such as the upward tension T and the weight of the rod W. So, before we proceed with writing our equations, let's first convert some values and do initial calculations. So, let's convert the length of the rod because it's in inches. So, let's convert it to feet. So, that would be, so L equals 30 inches times the conversion factor 1 feet is to, or 1 foot is to 12 inches. So, cancel inches. So, this would be equal to 30 over 12 feet. And aside from this, we can also calculate for the mass of the bullet and the rod from the given weight. So, because what we'll be needing is the mass, not the weight. Okay, so for the mass of the bullet, so mb, so that is equal to the given weight of the bullet divided by the acceleration due to gravity. So that would be 0.08 pound over 32.2, so the value of g in feet per second squared. Okay, so this will be equal to, so 0.002484 pound second squared per feet. And then for the mass of the rod, so we have mr equals, so the weight of the rod divided by g, so that would be 15 pounds over 32.2 feet per second squared. So this is equal to 0.4658 pound second squared per feet. We can also get the moment of inertia of the rod. So since it's a rod, so its moment of inertia is given by, so I equals, so 1 over 12, the mass of the rod times the length squared. So, this will be equal to, so 1 over 12 times 0.4658 pound second squared per feet times the length, which is 30 over 12 feet squared. So, this is equal to 0.2426 pound second squared feet. Okay, so those are the values that we have. Now, let's write an equation for the moments about point G, taking the counterclockwise direction as the positive direction. So, doing that, we'll have mb v sub o times h equals I omega. So, rearranging the equation so that we'll have an expression for h. So, we'll get, from this, so we'll get h equals, so I omega over mb V sub O. Okay, so this is our equation number 1. Now, so we can also write an equation for the linear momentum along x. So along x, it would be, so V sub O equals mr Vg. So rearranging the equation to get an expression for Vg, so we'll get, so Vg equals mb over mr times V sub O. So this is our equation number 2. So for the instantaneous center to lie at point C, so the condition must be, so Vg must be equal to, so Vg must be equal to 3 over 2 L omega. So that's the condition. So that's our third equation. So since we have two equations for Vg, so we can equate those two equations. So equating equations 2 and 3, so we'll have, so mb over mr V sub O equals 3 halves L omega. So solving for omega, so omega is equal to, so mb over mr times VO, then multiplied to the reciprocal, so 2 over 3 L. So let's substitute the values that we have so that we could get the value for omega. So this, so mb is equal to 0.002484. I'll be omitting the values, the units, for convenience. And then over 0.4658 times V sub O, which is 1,800. And then 2 divided by 3 times the length, so 30 over 12. There. So this is equal to 2.560 or 2.56 radians per second. So solving for h from equation 1, so we can now solve for h since we now have the value of omega. So solving for h from equation 1, so we have, so h is equal to, so 0.2426 over 0.002484 times 2560 over 1,800. Okay, so this is equal to 0.1390 foot. And converting this to inches, since the original values are in inches, so this would be, so h equals 0.1390 foot times the conversion factor. 1 foot is to 12 inches. So this would be equal to 1.668 inches.